Good morning, students. In the last lecture, we discussed about the perfectly black body and we also discussed about the artificial black body. Today, we are going to discuss emission of heat radiation. In 1792, Prevost put forward his theory of heat exchange. In 1792, Prevost, it is the name of scientist, which put forward a theory of heat exchange. According to this theory, all bodies above the room temperature, above the 0 degree Kelvin, all the bodies above 0 degree Kelvin absorb the heat radiation from the surrounding. Also, they emit the heat radiation from them. So, on which factor the absorption rate and the emission rate depend upon? The emission rate is depend upon the surface area, the temperature of the body, the nature of the body, and the time for which it emitting the heat radiation. We observe that a hotter body whose temperature is more, a hotter body emit the heat radiation at a maximum rate or higher rate, and a cooler body emit the heat radiation at the lower rate. And also the white body, which reflect most of the radiation, is a emitter less emitter, and vice versa. So we can say that according to the Prevost theory of heat exchange, hotter body radiate heat at the higher rate and the cooler body radiate at the lower rate. Now, what happen when a heat radiation fall on the body? For example, consider a body of any shape. The heat radiations are incident on it. So it is also depend upon what type of body is this. This body is a good absorber, then this body will absorb most of the radiation incident on it. Now, as it absorb the heat radiation from the surrounding, it emit the heat radiation to the surrounding. So we can say that it also emit the heat radiation in the same way it is absorbing. So what happens when a heat radiation is incident on such type of body? It get absorbed, and at the same time this body emit the heat radiation. If the rate of absorption is greater than the rate of emission, if the rate of absorption is greater than the rate of emission, then we can say that the body get heated. And if the body emit more than it absorb, we can say that the rate of emission is greater than the rate of absorption, then the body get cools. But what happens, the rate of emission and the rate of absorption, they are both are same if the temperature of the body is constant. This heat exchange is continue till the temperature of the body get constant. It come to the room temperature. So we can say that the rate of absorption is equal to the rate of emission to keep the body at the room temperature. Now, when the heat radiations are falling on the surface, what happen? it the constituent particles of the body, the constituent particles means atom, they absorb the heat, they absorb the energy, and they are vibrating with a maximum amplitude with about their mean position. Now, as they are vibrating with the maximum amount, we say that the kinetic energy of the body is depend upon the temperature. Is kinetic energy get increased? What happens when a heat radiation incident on the body? The constituent particle vibrate more about the mean position, so that the kinetic energy of the constituent particle get increased. And we know that the kinetic energy is depend upon the temperature of the body, so we can say that as the heat radiation are get absorbed or incident on the body, its temperature goes on increasing. As the temperature goes on increasing, according to the previous theory of heat exchange, it start emit the radiation till the temperature of the body is equal to the room temperature. So the rate of absorption equal to the rate of emission. What happened in the 11th section, we learn about a cup of tea and ice kept in a plate. What happens when a hot tea is kept in a surrounding, the heat emitted at a higher rate and the heat absorbed at a lower rate, so that the temperature of the body, temperature of the tea decreases and the temperature of tea become equal to the room temperature. As well as in the case of ice kept in a plate, what happens, it absorbs more and emit less. The rate of absorption is more and the rate of emission is less. So it absorbs the heat radiation from the surrounding until the temperature of ice, that is it become water, and the temperature of the surrounding become equal. So in the 11th section we already learned about the heat radiation, emission and absorption. So in this case, on which factor this rate of emission is depend upon? This rate of emission is depend upon the temperature, is depend upon the surface. Which type of surface is this? Either it is polished surface or it is a black surface. For how many much time it is emitting the energy, emitting the radiation, on the temperature of the body, on such factor this rate of emission is depend upon. What happens when a body gets heated below 800 degrees Celsius? When a body gets heated below 800 degrees Celsius, it is much higher than the room temperature, so it will radiate energy, the rate of emission will be higher, but we can't see the radiation are emitted by such body, because the wavelength of such radiation lies in the range of longer wavelength, and which can't see such longer wavelength radiations. So till the 800 degrees Celsius or below the 800 degrees Celsius, the body emit the radiation, but this radiation we can't see because they lie in the longer wavelength region. As the temperature of the body increases, if the temperature of the body increases, the body emit the heat radiation, but now this heat radiation lies in the shorter wavelength, and this shorter wavelength color we can see by our eyes. So when the body heated above the 800 degrees Celsius, we are going towards the 3000 degrees Celsius, we can see the heat radiations emitted by it. For example, a bulb which is the filament of the bulb which is about 3000 degrees Celsius, we can see that the color of this radiation is red. As the body increases further, as the temperature of the body increases further, its color also get increase, color get changed. So in this way, as the temperature increases, the color of the body appearing to us also changes. So on which factor the radiant power or the emission power of the body depend upon? It is depend upon the nature. It is depend upon the nature of the surface. It is also depend upon the area. It is also depend upon the temperature, and it is also depend upon the time for which it is emitting. So, how we can define a term radiant energy or emissive power, radiant power or emissive power? So, we can define such radiant power as R is equal to the amount of heat radiation falling on unit area per unit time. That is R is equal to Q divided by 80. This term R, it is called as the radiant power, or it is also known as emissive power. So what is R, what is emissive power, what is the radiant power? The amount of heat incident on a surface area A per unit time. Therefore R is equal to Q divided by 80. So why we are saying this Q is equal to heat incident? Because the incident heat and the emitted heat, they both are same if the body is in the thermal equilibrium. So we can say that what is emissive power or radiant power? The amount of heat emitted per unit area per unit time, it is called as the radiant energy, or it is radiant power, or it is also called as the emissive power. So in this way, in this lecture we discuss about the radiant power and emissive power. So what are the dimensions, what are the dimensions and SI unit of this radiant power or emissive power? We are going to discuss in the next lecture. So this is for today. Have a good day. Bye.